GM, everyone! Welcome back to the channel. Today, I'm excited to share a project I built on top of the Conflux network, deployed on the Conflux Testnet. This project is designed to manage investment clubs where anyone can create or join a club, raise funds through proposals, and let the community decide on execution and closure through a DAO-style governance model. In simple terms, it's a combination of fundraising, investment management, and DAO-based automation. So, let's dive right in. To begin, I'll create a new club. Once the club is created, members can start contributing funds. Contribution is essential because all project funding and distributions will happen from the club's balance. At first, the balance is 0, but once I contribute 0.01 CFX, the balance updates and now the club has some funds to work with. Next, let's move on to creating a proposal. A proposal contains important details such as the description, the club name, the requested amount, the CID, which serves as proof since all proposal data is uploaded to Lighthouse, the proposal name, and the destination address. Each proposal comes with a voting deadline, and before this deadline, members of the club can vote either for or against the proposal. After the deadline passes, no further votes can be cast. Now, one of the key principles of DAO governance is that the creator of a proposal cannot vote on their own proposal. This ensures fairness and transparency. Once voting is complete, the outcome determines the next step. If the for votes are greater than the against votes, the proposal can be executed. If not, the proposal can only be closed. In my case, the for votes were fewer than the against votes, so I wasn't able to execute it. Instead, I closed the proposal, and the transaction confirmed its closure on-chain. And that's the flow of this project. We started by creating a club, contributing funds, raising a proposal, and then managing it through voting, execution, or closure, all governed by decentralized DAO rules. This project demonstrates how the Conflux network combined with DAO automation can create a transparent, secure, and decentralized fundraising system. Now let's understand the code. The contributeClub function is how members add funds into the club. When a member sends CFX through this function, the amount gets added to the club's total balance. This balance is what the club uses to fund approved proposals. Without contributions, proposals can't be executed since there would be no available funds. Together, joinClub makes someone a recognized member, while contributeClub ensures the club has actual funds to support projects. The joinClub function allows any user to become a member of an existing club. By calling this function, their address is recorded as part of the club's members list. This is important because only members can later contribute funds, create proposals, or vote on them. The createClub function takes the club name and password from the user, saves the club data to Lighthouse storage, then calls the smart contracts createClub method with the club name and the storage CID. If the transaction succeeds, it shows a success message with the transaction link. If not, it shows an error. The createProposal function lets a user create a new proposal inside a club. It first checks the inputs, description, destination address, amount, and password. If valid, it unlocks the user's wallet, converts the entered amount to WAY, and uploads the proposal details to Lighthouse storage, which returns a CID. Then it calls the smart contracts createProposal method with the club ID, amount, destination, description, and CID. If the transaction is successful, it shows a success message with the transaction hash, otherwise, it displays an error. The runProposal function is responsible for finalizing a proposal by either executing it or closing it. It first validates the user inputs such as the selected action and password, then checks the proposal details from the contract to ensure that the voting period has ended. If the user chooses to execute, it calls the smart contracts executeProposal method, and if the user chooses to close, it calls the closeProposal method. Once the transaction is sent through the connected wallet, it displays a success message with the transaction hash link, otherwise, it shows an error. The voteOnProposal function allows members to participate in the decision-making process by voting on an active proposal. It ensures that the voting period is still open, validates the user's voting choice, and prevents duplicate voting by checking local storage. If valid, it calls the smart contract's voteOnProposal method with the proposal details and records the user's vote. After a successful transaction, it confirms the vote, updates the record to prevent revoting, and shows a success message with the transaction details. Let's understand the smart contract integration. This Hardhat script is used to deploy the Investment Club smart contract to the blockchain. It first loads the contract factory, which acts as a blueprint for deployment, and then calls the deploy function to create a new instance of the contract. After waiting for the deployment to complete with .deployed, it logs the deployed contract's address to the console so the developer knows where the contract is located on-chain. There is also a commented outline that, if enabled, would save the deployed contract's address into a config.js file, making it easy for the front-end application to interact with the contract. Finally, the script runs the deployment process and ensures that any errors are caught and displayed. This Hardhat config file sets the Solidity version to 0.8.10, defines networks, local Hardhat and Conflux eSpace testnet, and includes an accounts task that prints all wallet addresses. It also stores the private key so you can deploy or interact with contracts on the eSpace testnet. Thank you for watching.